Constant proportionality of graphs. This combines everything that we've done. And to tell you the truth, there are absolutely two things that you need to memorize for this lesson to work. The first one is super easy. The second one, for some reason, a lot of people are struggling to remember it. Okay? So a lot of people are struggling to get this concept. In order to head that off, we are going to do a short experiment to see if you guys remember how to do something. Now, here I'm going to have a graph. Okay, there's my y-axis. There's my x-axis. I have my x-axis here. We're going to have it be 1, 2, 3, 4, 5. 1, 2, 3. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4. All right. Now, if I had another line on this graph, not only if, but I'm going to make one, and I'm going to make it to be red. And it's going to go like this. And put this here. Put this here. Now, if I had this line, and I asked you, what are the coordinates of any of these points? Could you tell me some of them? Okay? So if I were to say 2, 3 is right here, would you agree with me? Okay, because it's 2 on the x-axis and 3 on the y-axis. Now, if I were to ask you, what are the coordinates of a spot on this line where 1 is the x coordinate? Where is the y? Sydney, where is the y? If my x coordinate is 1, what is my y coordinate? Where x equals 1. Corey? 0. So when my coordinate is with the 1, the y is 0. It's a line, it's a plot point on that line. Abby? It is 2. It is 2 because when 1, you go up or down. Today it can go down as well, okay? It can go down as well. For example, if that line were like this, then that would be right here on that point, okay? If you can recognize that wherever the line meets on the x-axis of 1, where that 2 is, you're going to be in good shape for both things. The first one is easy to remember. The second one, if you knew where Abby just got that 2, you're in good shape. Okay? So there's the precursor warning for those who are watching this YouTube video tonight because you don't understand how to get that. Okay? All right. Now back in action. Warm up. Now this is what's coming through from Wednesday, Thursday, and Friday of Tuesday, Wednesday, and Thursday of last week. Tell if the table is proportional, explain why or why not. The main concept of this is, and I'm really sorry if I'm talking fast, you can slow me down on YouTube, but I really want to make sure we get through this, the whole thing. Whenever we're trying to find whether something is proportionate, we have to find out if the ratios are proportionate with a table. Does anybody remember what I need to do to find out if these tables have a proportionate ratio? Yeah?
Is it you do like the y, whatever the y is?
Yes?
Equal to x?
Oh, close. Close. You might be thinking of this, and we're going to get to that.
Yeah.
Okay, we're getting to that.
X, you do number x, and then plus, and then
Right, that's how we find an equation for it. Good. That's from last week. Okay, thinking time over. It's y over x. Whoa. It's y over x. So for example, for this one, I would have 0.5 over 1, which is going to be 2. Or sorry, 1/2. Then we have 1.5 over 3, which is also 1/2. We have 2.5 over 5, which is 1/2. We have 4 over 8, which is 1/2. And we have 4.5 over 9, which is 1/2. All of them have the exact same ratio, 1 to 2, or 1 over 2. Okay? Since they all have the same ratio, that means yes, they are proportionate. Do you remember this from Thursday? What about Wednesday? Yeah? It's all proportionate. Then we have to give the equation for each table. All you need to do is just do multiplied by x, and there's our y. Okay, that one is good. Now with this one here, we have a zero check, the zero trick. Right away, we can tell that is not proportionate because there's going to be an extra operation going on there. We're going to have an extra operation going on there. Now, for time reasons, it's going to be y equals x plus 6. It's not proportionate because it has to be like this when you have a proportionate. It has to be y equals kx, and this is our COP, our constant of proportionality. Do you remember that? Right? If there's anything else, any other junk right here, plus whatever, okay? If anything is there, it's not proportionate. You can tell right away from the equation. Then finally we have this guy. Yes, it is. It's 2x. Everything is 2. That's a review from Thursday. Sam, please pick up your head. Everybody, sit up straight in your desks. Okay? Let your neck do its job. Let it hold up your head. The black line is proportional. The blue line is not proportional. Okay? I'm telling you that right now. Black line is proportional. Blue line is not. Now we're at the guided notes part. What can you tell me about these two lines? How are they alike? How are they not alike? Other than one is blue, one is black. Sam, what's something you can tell me? They both go through all the corners and squares. Good. All right, yeah. Jace? Okay, one is proportionate, one is not. Good. Danny, you got something? Yeah, one is facing one way. Do you guys remember that toboggan that I drew? Okay. Didn't I draw a toboggan? Okay. All right. So that one's going down. It's a negative thing and this would be going positive. All right. Good. What else? Yeah. Okay, what was it?
It was like one, the black line was closer to like the negatives.
Okay. Well, they both do because that blue line goes far up left. So that goes in the negative x value. So, yeah, I like it, though. I like it. Sam? They do intersect. Yep. They have a common point. They have a common point. Let your neck do its job. I can see it blinking. I said, let go of your head. Let go of your head. Yeah. Seriously. I don't know if it's because it's warm here, but I'll have you stand up. Yeah, that'll keep you awake. Proportional graphs are straight and go through the origin. I want you to write down, forget the are straight. Of course, that's going to be straight, all right? You're going to highlight that. Proportional graphs go through the origin. Write that down to the right of this example. Do it to the right and highlight it. That means you put around that boxing because that's one of the two things that you need to remember for tonight's homework. Proportional graphs are straight and they go through the origin. So you're just writing down, where? Proportional graphs go through the origin. The origin is 0, 0. The origin is 0, 0. The origin is 0, 0. Yes, sir. So that is magic number 1 of things that you need to remember. Ugh. Whatever. No, 7s are here. And 1s are very similar to it, but it drops. Now here's the other thing that you're going to write. Since you know what the COP is, and I'm not talking about law enforcement, COP is the constant of proportionality. Yep. You are going to highlight this. So you can write COP is the y value when x is 1. COP is the y value when x is 1. COP is the y value when x is 1. So I guess I could do this. I didn't do this for the other classes. So whatever coordinates there are on that graphed line, it's 1, comma, COP. Yeah, this is a unit that we purchased to prepare you guys for park testing. So there's like 6 questions that had to do with constant proportionality that were like, yep, this is new. So you guys are the first ones to ever have this unit in District 7. All right, does this make sense? See this 1, comma, COP? Does that make sense? Do you see where I'm at here? Okay, 1, comma, COP, because if I wanted to plot any point on this one here, if I wanted to do this, it would be 2, 2. Yeah? But, so this would be this point here, whatever 1 and 1, that's on this line, so that means that since x is 1, that means that the COP is 1, and that's what it says right here.
So if the COP is 1, that means that...
Yeah, if COP is 1, then the formula would just be this, y equals x. Okay? All right, let's get some more practice. Right away, is the graph proportional? Is the graph proportional? Look over Jace's shoulder and copy down what you missed. No. Why do you say so? You're right. Yes, you are. Boom. What's the 2 things you need to remember for today, folks? What's one of them?
The origin is 0.
The origin is 0, 0, but what about the origin? Yes, graphs are proportional if it goes to the origin. What's the second thing you need to remember? Yep. The COP is the y value and x is 1. Right here, it didn't follow the first one, so no, it is not proportionate. It doesn't go through the range. So there's no constant of proportionality because it's not proportional. Constant means ongoing. Yeah. Yes, ma'am.
What about the origin? I know that it has to go through the
Oh. The what?
About the origin. Say something else about it.
It's 0, 0. The origin is 0, 0. It has to go through that in order to be proportionate. This one here wasn't, and Sydney knew that, so she said it's not it. Yes. How about this one? Is this one proportionate, Lainey? Okay. Blake, is this proportional? Yes, it is. How do you know? Great. It is proportionate. Now, here's the tricky part. It's not tricky, but this is what people were having trouble with. What is the constant of proportionality in this graph? So what I'm asking you is, what is the y value of the blue line when it crosses the red line? Harrison. Have you ever had a constant proportionality be an ordered pair in the last week? No. What is it? Yes. Yes. Negative 0. When, come on. There we go. The y value when x is 1. So do you agree that this point here is 1, 1? Okay? So as we had a couple of slides back, and as hopefully you wrote down, do you agree that the x value is 1? When the x value is 1, isn't that the cop? So, wait, shoot, there. This is 1, negative 1. And when the x value is 1,
so why wouldn't you do it
over here?
Yeah,
Because that's not the x value of 1, that's negative 1.
okay.
Yep, I could even have it be like this. This is not going to be straight, but this one, what would the cop of this one be? Ready? 0? Nope. When the x value is 1, yes. No. When the x value is 1, what is the y in the red? JD? 1. No. Okay, I'm going to do this again. This blue line represents the 1 in the x value, where the blue and the red meet from the ugly lines that I just drew. What is the y value, Max? 10. Yes. 10-ish. It's ugly, but 10. It could be 9. I just don't know how to draw a straight line when I'm trying to find more ways. It was right. It was like right there. Okay. All right. Yeah, of course. School's 90 years old. It's got to be on it, right? Gummy bears. It's spelled like that because maybe they might be trademarked. I don't know. Sam, pick up your head, Sam. Now, situation. Gummy bears. Price is on the left. The pounds are in the bottom. Okay? Price is on the left, pounds are on the bottom. Now, in this situation, well, first off, let's find the constant of proportionality. And I really hope that that last slide helped, because we need to find out when x is 1, where does the line hit the y? Who haven't I got yet? Jake? And it's not going to be spot on. It might be off a little bit tonight on the homework. It's off just a teeny tiny bit. Yes. 2. Guys. Yes. 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 All right. You want a high five too? Oh, yeah. No, wait, no. Are you bored or you have to use the restroom? Be honest with me. When you come back, you better be awake. Splash some water in your face. You're falling asleep. Now, it's 2 because that's where the line meets x on the y-axis. Okay? All right? Now, what does that represent? The constant of proportionality on this one. What does it represent in this real life situation where I got price I got weights. What does the constant proportionality mean? Remember, we just found out that it's 2. Jake said that it was 2, and it was awesome. Bello. How much does it cost for 1 pound? Yes. And what does it cost for 1 pound? $2. Beautiful. So it says here it means 1 pound costs $2 or $2 per pound. It's actually a unit rate. Yes. I'm sorry. Can you repeat that? Cents? Cents. Right. Yeah. Yeah. Actually, this should say price in dollars. Price in dollars, and that one should say. In this situation, it does. That's actually a pretty good price. A pound of gummy bears? Okay, quiet. How about what does 0 mean in this real life situation?
0 pounds, 0 pounds.
Elena? Yeah. And how much is no gummy bear is going to cost you? Yeah. So So wait, this is a pretty good deal, guys. Okay, you don't have to pay for the gummy bears you don't get. Right? Thanks. Thank you. See, I'll let you do that. I'm not going to make you pay for the gummy bears you get. Okay.
Wait a minute, Mr. Smith, I have a question about this. Okay, so you said like they're meat, right?
Meat?
So yeah, like.
Oh, MEET, not MEAT. Okay.
So 5 and 10 meat, so that would be 1 too.
No. Well, yes. 5 and the student is asking where they meet at different ones. 5 and 10 is also one. All this is saying that for 5 pounds, it's going to cost you $10.
Yeah, and
It does, but not where X is 1, and that's the second thing you're supposed to memorize. There's just 2 things you need to memorize, and you didn't highlight them. Okay, I need you these 2 things. One of them is that it has to go through the origin in order for it to be proportional. The second one is the COP is the Y value where X is 1. Kim bought a pound of grapes for $1.50. A pound of grapes for $1.50. It's a pretty good deal. How much will she pay for 2, 3, and 4 pounds of grapes? This here, whenever you see something straightforward like that, where you're just multiplying the amount times the price, you know that it's going to be proportionate because it's all going to be the same. There's nothing else added to it. There's no tax. There's no refills. There's no whatever it might be in your homework or test. Okay? So all we need to do is just multiply. 2 pounds, when 1 pound costs $1.50, is simply going to be $3. Plus another pound is going to be $4.50 if I knew.
would it just like be $3?
Then plus 1 more pound is $6. What's your question?
Would it just be like $3?
Tap this down for her. There's no tax in the situation. We're acting like we're buying out of state. Now, remember, we have to write an equation for this. So it's going to be y equals kx plus something, maybe. Okay? She's copied down what you missed. All right? So we found that. What's the equation for this situation? It is proportionate, so there's not going to be any stuff here. Harrison? Beautiful. Y equals 1.50x. I'm just going to keep it 0 in there because we're dealing with money. You don't have to have it in there. It would come out the same. Now, is that... Oh, we decided that it is proportional. What's the constant in proportionality? Jace? $1.50. It's just 1.5. 1.5, because the constant proportionality, you don't need to have a unit.
You said it is proportional.
1, 2, yep, 3, 4, 5. 1, 2, 3, 4, 5. Now, I am not going to be able to put this line anywhere in the negatives here. Because can you have a negative amount of grapes and a negative amount of weight? No, there can be a difference, like if you lost some weight or if you had so many grapes and then somebody ate them, or you ate them and they had that much less. But this is just a fact of having them or not. You can't have a negative amount of grapes. Okay? So let's graph this. Now there's two different ways. Remember the tables that we did on Tuesday when we were graphing from tables? Yeah. This one is going to be my x value, which is going to be the, let's go pounds. This is going to be the y value, which is going to be price. So when I have 2 pounds, there is $3. There's 1 point. 3 pounds is $4.50. 4 pounds is $6. 5, 6-ish. Then I'm going to take my school-issued straight edge and draw a graph line. Put an arrow at the end of that. So, now that I have it graphed, the $1 million question is sneeze. No, the $1 million question, what is the COP here? The COP, yeah, you know me. Sydney? There's 2 ways you can answer this question, by the way, right now. It's both going to be the same answer. Nope. Lainey? 1.5. Because A, it's right here. That's from Thursday. And 2, when I go from my 1 value and I go up, it's going to be at 1.5 right here. That's where that line crosses the 1. Uh-huh. Uh-huh. Okay. There it is. Yes, it's proportionate. The COP is 1.50. Real quick, tell if the graph is proportional and give the constant proportionality. Number 1, is that proportional? Everyone. Why? Beautiful. Yes, it does not go through the origin, so it's not proportional. That's the one of the 2 things you need to memorize for today. The next one, is that one proportional? Yes, it is. It is proportional, and when I want to find out what the COP is, I go to 1 here, and I go 1, 2. It's at 2 on the y-axis, because here's 1. Okay, it's at 2. So the COP, C-O-P, equals 2. 2, just 2. They just want the COP. Right? Or go down the hall to Officer Davis. Right? No, her office is up here.
I thought her office was downstairs.
No, Officer Davis's class is here. All right. Yes. All right. This one here, it says pounds and price. Because look at the question. Stephen can ride 12 miles in 1 hour on his bike. How many miles will he ride in 3, 5, and 6 hours? Pounds, price.
That is awesome.
So this should be miles. No. That's hours. Oh, hours. Hours and miles. And as you do this for the next couple minutes, I'm going to pass out your homework, and then I'll reveal the answers after I pass them out. Yes. Yes. Yes, sir. Yes, ma'am. Don't write you're working on this right now. Did you finish that last example? Where's your graph? Yeah, finish the last example. So let's write the equation, graph the equation, tell if it's proportional, give its constant of proportionality, all that stuff. Oh, yeah. Wednesday, covering this unit. So that means that I'm going to get your guys' homework from this unit back to you guys tomorrow. Okay? So that's what I'm doing. Yeah. So rather than getting your notes back to you from last unit, I'm going to get your homework from this unit back. So I couldn't get in here this weekend. When I was going to, I wasn't able to. And then Sunday, I wanted to make sure they could clean it up here. Yeah. And tell why. No, you would give the equation stuff, right? Isn't that how it works? Good idea. Uh-oh, what's this? Oh, Owen. 10-9. Remember, we were looking for that? It was jammed in the back of the... That's good. So you have it. It was in there jammed in the back, yeah. No. But if another one turns up like that, I'm going to be suspicious. Here's the answers. Bye, YouTube.